Okay, guys. So here's our notes page for today. Yesterday we talked about single transformations, like what actually happens when you change your parent function in one way or another. Today we're going to be talking about composite transformations. Okay, and a composite transportation, so that's what goes right here in this blank. Composite transformation. Okay, a composite transformation. Sorry about the glare. No, occurs when two or more transformations are performed on the graph of a function to produce a new function. I'm going to rewrite that in a different color. So yesterday we only applied one change to a graph or to a function. Today we're going to be combining all of those transformations on to one function. So several things could change in today's. Okay? This says absolute value function. It says to determine which transformations have been applied to an absolute value function, consider the following questions. Okay? These transformations work on any function. Okay? So this, I believe, is just a typo. This should be a linear function. Okay? But the same transformations happen no matter what type of function. The same things happen. But we're only dealing with linear functions right now. So the first step that you're going to do is you're going to check for reflection. So is the variable multiplied by a negative value? So your variable that it's talking about is your x. Okay? Is your x or your function, okay, multiplied by a negative value? So right here, here's an example. We've got y equals negative x. Okay, so that's a negative multiplied by the x right there. If I zoom in too much, then. Okay. And then right here in this next example, it's a negative 5 times x. So I've got y equals negative 5x plus 1. We are only looking for that negative sign that's out front there. Okay? When we're looking for reflection, we don't necessarily care what the number is. We only care about the negative sign. If there's a negative sign being multiplied to your x. Okay? So over here in the non-examples, okay, this is a y equals just x minus 7. This minus 7 is not a negative being multiplied. That's being subtracted. And right here we've got y equals 1/2 x. So this 1/2 is also not a negative. So reflection only occurs, okay, when there's a negative being multiplied. And the reflection changes the slope from positive to negative. Okay? So it changes your positive slope to a negative slope. Okay? Or vice versa, it changes your negative slope to a positive slope, depending on what your original function is. The second thing that you're going to check for is vertical and horizontal stretch or compression. So notice this paper that I gave you, or that you picked up that I printed in color for you. Okay? Notice that it uses the word dilation. You'll come across that word more in geometry than you do in algebra, but dilation encompasses both the stretching and the compression. Okay, both stretching and compression together is called dilation. So if you see that word, just know it's talking about the stretch or the compression. And when these change right here, the phrases that you want to use in this is more steep or less steep. Okay? You can use narrower or wider. You can use taller, but these are what you're going to see more often, more steep and less steep. Because the dilation, I'm going to move that up a little bit. I don't know if I can get it all on the same thing because I've got it zoomed in so much. Okay? Because the dilation down here in our blank, okay, the stretch and compression changes the steepness. And my pen is too fat. I can't get it to fit on that short little line. So changes the steepness of the graph. So some examples are multiplying this x. Okay, notice that this is multiplying. Okay, same thing up here with reflection. We're multiplying. Both of these first two steps are talking about if things are being multiplied by the variable. Okay? So right here, 0.2x, so 0.2, is that greater than or less than 1? Which category does it fall in? Does it fall in this greater than 1 or this between 0 and 1? It falls between 0 and 1. So this is compressed. It's either vertically compressed, or if you're using the horizontal, then it's horizontally stretched. If you choose to use the words stretched or compressed, you have to also use the word horizontal or vertical. So just know if you choose to use those words, they should also be paired with either vertical or horizontal. So this would make your graph taller, right? Nope. This is confusing right here. Okay? A is tall, but making it stretch gets taller. Okay? So stretching it gets taller. Compressing it gets shorter when you're talking about vertical stretch. So if we're looking at my A here being between 0 and 1, if I'm using this information, then I have to use the word shorter. If I'm using this information over here, then my stretch for horizontal, we could use the word wider. Or my compression would be narrower. This is why we tend to just say less steep or more steep. Because if it's less steep, then that tells me both it's shorter and wider. And more steep tells me it's taller and narrower. This next example multiplies by a -5. But we've already dealt with this negative when we talked about the reflection. So we're only looking at the number 5. Does the number 5 fall Greater than 1 or between 0 and 1? Greater than 1. So it's going to stretch it vertically, make it taller, or it's going to make it narrower, compress it horizontally. There's all kinds of ways to describe it, guys. You just need to know what it's talking about when it does describe it that way. Makes it more steep because it's going to make it taller. Non-examples are when it's just a 1 in front. So right here, y equals 1x minus 7. Well, that 1 doesn't change the steepness. Okay, this negative 1 here in front of this next x doesn't change the steepness. It got reflected, but the steepness didn't change. The third thing that you're going to check is vertical and horizontal translation. Okay, so this is shifting it up or down. Okay, shifting or moving. Okay. To shift or to move it up or down or side to side. If you don't want to write translated, then shift is the most common used other word. So, and this is when you have something added or subtracted from the variable. So the first two, right, we're dealing with multiplying things times the variable. And this one is dealing with adding or subtracting things to the variable. So we don't care about the number in front of the x, we only care about what's being added or subtracted on the end. So in this example, this negative 5 would shift the line up or down? Down, how many units? 5. So it would shift it down 5 units. Okay. Over here in this next one, it adds 1. So how is that going to shift it? Up 1. Okay. So these non-examples, notice that there's nothing being added or subtracted. It's just a single term, right, with nothing being added or subtracted on the end. So it didn't get shifted at all. It stayed at the origin. Translation changes the location of the intercepts. We usually talk about the y-intercept because it's the easiest, but they do change the x-intercepts as well, not just the y-intercepts. So in this next set of examples here, does everybody have all that information? So in the next set of examples here, it says, the graph of the function g was obtained from the graph of the function y equals x. That's our parent function, right? We just wrote it as f of x equals x yesterday. But your Get More Math puts it in y. So using a composite transformation as shown on the grid below. Describe how the transformation affects the slope and y-intercept of y equals x. So in order for me to see what happens, first I'm going to zoom in a little bit more. But I'm going to graph my original parent function on here. Okay, I'm just going to do it with a series of dots so that I can keep them separate. So it starts at the origin, goes up 1 over 1, up 1 over 1. So it's going to go straight through my graph like this. That's my original y equals x line. So now that I can see what my original line is, I can compare what happened in the new line. So my original line has a positive slope. Did the positive or negativeness of my slope change? Is it still a positive slope? Is G still positive? So there's no reflection. So that was the first step. The second step is to check for vertical and horizontal stretch and compression. So did my graph get more steep or less steep? So I'm comparing from my original graph to my new graph. So my new graph is the one that they graphed for me, the G right here. Okay, my dotted line is what it changed from. So that's my original to my new one. So my new one is more steep. More steep. Okay. You could also say it's narrower. Oops. You could say it's narrower. You could say it's taller. Okay. But more steep is how that you will see it most of the time phrased. And then the last step is to determine whether or not it was translated. So did my y-intercept change? Did it? Started out at 0 and now it's at where? -2. So it shifted down 2 units. Okay? It shifted down 2 units. Notice that I don't say shifted -2 units. Okay? You use the description up or down and however many units it is. We don't use positive or negative when we're shifting. So it shifted down 2 units. So go ahead and draw your original parent function on the next one. Start at your origin. Okay. And it goes up 1 over 1, down 1, back 1, whatever. That's your original parent function line. All right, so you can compare the two. So first off, was it reflected? Did it change from a positive slope to a negative slope? Yes, so it was reflected. Did the steepness of the line change? No, because if we look, my slope is still the same, up 1 over 1, and I go up 1, back 1, so my number is still 1, right? So there was no change in steepness. Goodness, doesn't want to write right there in that one spot. No change in steepness. Okay. Was it translated or shifted?
Yes.
How was it shifted?
It moved up.
It shifted up 2 units. You can use right and left if you would prefer to describe how the x-intercept moves, but most of the time it's easiest just to do the y-intercept. So the last example on this side, okay, same thing, draw your parent function. You should know what it looks like at this point, right? Goes through your origin from corner to corner. So show of hands whether you believe that it reflected. So if you believe that it reflected, raise your hand. Okay. So Preston, are you awake or are you sleeping again today? Okay, just checking. Okay. So it did reflect because it was positive, right? And now it's going downhill. So it was reflected, so it reflected. And then the steepness. How did my steepness change?
It's less steep.
It's less steep. So it's less steep. Again, this is where you could also say that it's wider. Okay. It's wider. We don't like to use the word shorter, but sometimes that's what would say, mainly because, well, we can use shorter. Was it shifted any?
No.
Okay, so no shift or no translation, you can say as well.
How do you know it?
Because they both go through the origin, so it didn't move. So on the back side, so the linear parent function, f of x, is shown on the grid. Graph g of x on the same grid and describe how the transformation of f on f that resulted in g affected, sorry, let me reread that. Graph g of x on the same grid and describe how the transformations on f that result in g affect the slope and y-intercept. So this line right here is our parent function. It's f of x equals x. You can label it down here if you want, so it's not on the next example, either one. So notice this is written in function notation, like our handout here. Our handout is written in function notation. Okay. Are there any changes happening inside the parentheses here? No, right? So because there are no changes happening inside the parentheses here, I can substitute my x from my f of x right into my equation right there and make it look like something I'm more used to seeing. So g of x equals 1/2 x minus 4. Do I know how to graph this now? Where do I start? -4 on my y-axis. Okay, then what? Up 1 over 2, up 1 over 2. Okay. So here's my new line. Okay, this is my g of x line. So what changes happened to the slope?
It got
Got less steep.
It got less steep. This half right here, right? It's between 0 and 1. So that's a less steep line.
It shifted.
So got less steep. Did it reflect?
No.
Okay, so no reflection. Okay, and then it shifted. How did it shift?
Down.
Okay. Shifted down 4 units. Oops. Everybody with us still? Okay. So this next one says g of x equals negative. Which one? So negative f of x plus 5. We've already got our original equation there, our original graph. So I'm going to do the same thing I did a while ago, and I'm going to replace my f of x with just an x. I'm going to rewrite it. g of x equals negative x plus 5. I can do that because I know that f, my original equation, f of x equals x, which means if there's no changes happening inside my parentheses, then I can just substitute in directly for my f of x. Okay. Take that off of there so it's not confusing. So now, if I look at this, where am I going to start? At positive 5. Okay. And then what? Down 1.
Over 1.
how come we didn't find it? Like on the other one, did we not find it? Never mind.
Are you with us? Did you figure out what your question was?
Yes, ma'am.
So what changes happen to the slope?
It got steeper. Or it got steeper.
And so the steepness didn't change. Did it get reflected? Okay, so it reflected. But steepness didn't change. So same steepness. And then what about the y-intercept? How did it change?
It shifted up 5.
Shifted up 5 units. So last one on these examples anyway. Okay. So are there any changes happening inside this parentheses? No. So I can go ahead and just make the substitution, negative 5 halves x. So where am I going to start when I graph this one? At where? Not at 1. The origin, right? Because there's nothing being added, and when nothing is added, that's the same thing as plus 0, right? So then, how do I go from there? Down 5 over 2. Okay. And then go the other direction, up 5, back 2, to get you a third point. So how did my slope change on this one? Okay, let's start with reflected. Did it reflect?
Yes.
Okay. So it reflected. Okay. Did it get steeper or less steep? Okay. So let's use the word more steep. And then did we have any changes in the y-intercept?
No.
So we can say that it stayed the same. So we can say same. You can say no change. So down at the bottom, okay. So the third type of example that we have is the graph of g of x is obtained by transforming the graph of f of x equals x. Again, we're just translating the parent function. Okay. So my original graph, okay, we're going to graph both of them on here. So my original graph is going to be my parent function. Okay. That is a lot of dots. This graph got smaller on this. Okay. So you don't have to put all those dots. You can just draw your line too if you want. You should know what it looks like, right? It says we have to graph both of them. So we can't leave it a dotted line because it shouldn't be a dotted line. We know now that a dotted line means something different, right? Okay. So that's my original line. And it says the changes that I'm going to make is I'm going to change the slope, okay, to negative 1/4. And I'm going to change the y-intercept to 1. So I'm going to write my equation. Scoot this a little bit. So g of x equals, what did I change? My slope? So I'm going to start with my x right there in the middle, my f of x. That's what I started with. What am I going to put here in front? Changing my slope to negative 1/4, right? And I'm going to change my y-intercept, which means I need to add 1. Now, if I don't want to write this in function notation because I didn't make any changes inside my parentheses there, I could just rewrite it g of x equals negative 1/4 x plus 1. So where am I going to start at? At 1. Okay, and then what? Down 1 over 4. There's enough dots. So then it still says describe the changes that happened. So what happened to the slope? Okay, so it reflected. And then what? Less steep. And then what about the y-intercept? So if you've finished, then go ahead and graph your f of x line on your next graph so you can be ready for us.
That thing you did like Monday, I think, does that mean we turned it or do you see it? I'll just turn it.
Yeah. I'm not sure what exactly you're talking about.
Oh, the Desmos thing?
Yes. Oh, yes. I can see it, but turn it in on Google Classroom so I know that you went back and did it. If that I didn't already give you a grade for it. I got too many classes to know which class to keep them straight. Sorry. Yes. And I do have winners too, and I will announce those tomorrow. Hmm? They counted towards your grade. Okay. So there's my original F line, right? And the same thing for your notes yesterday too, Abigail. Was on Desmos. The notes were on Desmos as well. There was a video walking you through it, but you still had to do it on the Desmos as well. Okay. So now it says that our changes to our graph, we changed the slope to 4/3, and the y-intercept changed to -8. So my new equation, g of x equals, okay, what changes am I going to make to my f of x? I'm going to change the 1, that's the slope out front, to 1 or to 4/3. And then I'm going to subtract 8 in order to shift it down, right? Can I rewrite this? Did I change anything inside my parentheses here with my horizontal anything? No. So I can rewrite this. G of x equals, and just make it look prettier, right? That's all we're really doing. It's the same thing. And now we can graph this. Where are we going to start when we graph it? -8. Okay. And then what? Okay. So up 4/3. So did this one get reflected? Okay. So no reflection. Did it get steeper, more steep, or less steep? More steep. How do you know? Is 4/3 bigger than 1 or less than 1? It's bigger than 1 because 3 will go into 4 more than one time. So that makes it greater than 1. So it's more steep. And how was it shifted?
Down 8.
Shifted down 8 units. So you do have 10 Get More Math problems for today that's assigned. However, tomorrow's class period, all we'll be doing is getting anything that you needed done this week done. So you'll have class time tomorrow to do them. That doesn't mean you shouldn't try them, but so try them, but we'll be doing that in class tomorrow. They are due at the end of the day on Friday, so you can go ahead and
Did you skip this?
yes, those are your notes. They go in your